Hello, and welcome to this quick chat, part of Laser Focus World's PhotonicsNXT Fall Summit. I'm Justine Murphy, Senior Editor at Laser Focus World. I'm talking with Fel Legrand, the US and Canada Sales Manager at Gentech Electro-Optics, a company that provides equipment to measure laser beams and terahertz sources. Hello, Fel. Thank you so much for being here.
Thank you, Justine.
Well, why don't you tell us a little bit about Gentech, maybe some of the history of the company and what specifically you guys do?
Sure, I'd be happy to talk about this. It's great to be there. And we have a long history with laser beam measurement. We first started in the 70s building CO2 TEA lasers and joule meters to measure the pulse energy of those lasers back in the day. But now for 20 years, since the years 2000, we decided to only just focus on laser beam measurement. So we leave our customers build the lasers, and we provide the tools to measure the energy, the beam profile, and the average power out of those lasers specifically. So we offer a variety of products, from the picowatt range up to kilowatt range, for photodetectors, thermal biodetectors, or big calibrators to measure those lasers, as well as pulse-to-pulse energy measurement for pulse lasers and beam profiler. We have more like 500 products ready to go off the shelf, and a big portion of our business is for custom developments, just on demand, that we provide to our customers. Our main values of the company, I can sum it up as partnership, accuracy, and rigor. And we'll work with our customer to make the most precise measurement solutions possible and adapt to any laser system on the planet, basically. And a quick note, we're a growing company, we're hiring. I like to say we're a family, we're a growing company with family values on the global market. I like to put it that way. We are headquartered in Quebec City in Canada, with offices in the US and Japan, and calibration center in the US and in North America, in Europe, and Japan. So providing tools for measuring all various kinds of lasers around. And just to give you an example, we increased our production floor in 2020 by 60%. So we're growing, ready to address any needs in this field.
Okay. And can you describe some of the applications in which Gentech equipment is used today and why that's so important to integrate laser beam measurement into these applications?
Sure. Yeah, we cover a variety of applications, as you can imagine, anywhere where it's valuable to measure the laser power, energy, and profile at the R&D level, production level, quality control, service in the field, integration. Our customers, they need to quantify, for example, if they're running medical applications, medical devices manufacturing, surgical tools manufacturing, or equipment that's ending up in your body, like stents or equipment to help with the health, and it's a surgical operation. Those customers, they need the highest level of traceability to be sure that the tools has been manufactured using a laser, for example, a welder or a cutting system to manufacture those parts as accurate as possible. So they need the output power of the level to be really well defined and measured on a regular basis. So they need properly calibrated laser power meters to do so. So that's an example. Another field, manufacturing, of course, whether you're an OEM integrating your equipment into your customers' machines, or running a job shop with laser welders, laser cutters, surface treatment stations. You need a high level of repeatability to be sure that your parts are manufactured the same way from one batch to another, right? And as well for cost reduction in maintenance planning. So I'm using this laser welder every day. Do I need to measure its laser power output every day, every week, every month? We need to plan. And our customers are using our devices to plan the measuring cycles and strategy, and to reduce cost in planification, using good planification. So variety of application, I can go on and on. Another good example is scientific research, of course, from nuclear fusion to material development. Lasers are everywhere. And for meaningful results and good quality of research, you need robust quality equipment, reliable detectors, and that's what we provide.
What are some of the most important factors to consider when selecting laser measurement equipment?
Good question. It's first we need to rely on what we know of the lasers our customers are using. That's why we always ask our customers and partners. So, what is, for example, the laser wavelength, the min-max expected power that you have with this laser that you think you have, the beam size and the beam profile at the working point with where you're using this laser beam, and if it's a pulse lasers, the min-max expected energy level, the repetition rate, the pulse width. Then for how long do you need to measure the laser power? Just a quick check measurement or burning station for hours? It depends. And then the integration part of it. So where will you need to measure exactly? Just at the full power through full beam at the focal point, depending on your processes and operations? Will you use an optical peak-off that contains a small portion of the beam power? And is this relevant to go this way? So most of important factors for it. So laser specs or parameters, whether you're building a laser system or buying one, you need to know at least some of those specs and parameters. So there we can help. And more specifically, in terms of measurement design, for example, if my customer engineers, they're building a laser system, they're designing a laser system, they need to think how the system will be produced in the production line. So how many checkpoints will be needed in production for their colleagues to perform the measurements? They need to ask themselves those questions. And then when they provide, for example, the commercial laser system company, when they provide their lasers in the field to their customers, how the service team will access the measurement points. Is that inside of the machine, outside of it, free space measurement? And do they want to let the customers themselves, the end user, do the measurement, or it has to go through a contract, service contract on a yearly basis, for example? So this is important to consider when we qualify the equipment, because if you go on site, you might need to use just handheld single-shot power measurement devices, really easy to use, all included, versus like an integrated measurement that is more fixed, all those considerations. And as well, important factor in terms of data management. Where are you going to log in your information? Is that to a computer, to a standalone monitor, via a network, continuously over hours, or just for spot checks? What is the frequency of measurement? How do you organize data management, basically? And yeah, there's some important factors to consider.
Great. And what are some of the more significant technology and application trends that you're seeing in this field of laser beam measurement?
Well, that follows the laser developments itself, basically. We're seeing more and more from the industrial field, the industrial lasers that are produced by our customers. Let's say for manufacturing, we're talking, let's say right now we're between 5 to 10 kilowatts of laser processing power for cutting and welding. The trend is definitely to go within, let's say, 5 years or less than that, between 15 to 30 kilowatts for processing parts faster, once again for laser cutting, welding, surface treatment, for example. And with the high power fiber lasers becoming more and more affordable and implemented in the field, the biggest trend is to want to measure higher power levels, but as well as higher levels of power density, because people will like to measure the laser power at the focal point with a really high power density. So we need to adjust. We need to release higher gamma thresholds in terms of laser beam power density, energy density. And if you can imagine, if you can cut through metal in your laser cutting machine, there are higher chances that will cut through our detectors as well. So we need to as well talk to your customers, make sure you measure with a beam size that's big enough, and using the natural divergence of the beam, or using a beam expander, making sure you have a spot size that's big enough to not damage the detector. And in parallel, yeah, we're really seeing more and more absorbers for detectors that are resilient and with higher damage ratios. So that's how we stay ahead of our competitors. And a big trend in controlling diagnostics that we see is to use inline monitoring, which is, for example, dual laser power measurement and beam profiling, but real time when the parts are processed. Let's say you don't want to interrupt your production line. You go real time and you still get using, for example, an optical peak-off, the capability to measure the power and the profile simultaneously to your process. For example, in monitoring the beam power for additive manufacturing applications, laser pinning, we've seen that for marking and labeling accuracy in pharmaceutical production environment. That's really important to not disrupt the production line and to go real time. And another trend that we see is automation. The way to integrate those measurements in using serial commands or to hook up to an HMI and be sure this is well integrated in the machine that customers are using. Basically to comply as well with the requirements of the 4.0, 5.0 standards that are coming up and to be able to automate and communicate with those devices. So that are some trends we see.
Okay. So we know there are other laser beam measurement options available on the market. Can you describe what solutions you offer to the photonics community and what differentiates your solutions from other competitive offerings?
Sure. Yeah, we discussed a little bit already about the data thresholds in power density. So we like to put it that way, that we offer high-end performance with our detectors wrapped in cost-effective packages. So we provide the highest data threshold on the market for standard solution. We are talking up to 100 kilowatt per square centimeter for standard products of laser power density data thresholds. And we always provide for every standard product, any Gentech EO solution, we provide a NIST traceable calibration, meaning that we only use gold standards that we buy from NIST to calibrate our detectors that we sell. And as well, it's funny because we're still receiving for recalibration, but not repairs, just recalibration probes that have been made in the last century, in the 1980s or 90s, where our customers are still using those probes. They are functional, they work. They just need a regular calibration as any detector on the market. So they're very robust. And I can mention some product releases we had lately to differentiate ourselves from our competitors. For example, an automated M-squared measurement system with 2 inches optics. On the other hand, from the power measurement side, we have the single-shot power detectors, the Pronto series, which is pretty unique, all included and held ready to use, easy to use, up to 10 kilowatt of laser power. We have the single pulse to pulse energy measurement Max 6 series, providing up to 200 kilohertz single pulse to pulse energy measurement capability, which is very unique. And going from femtojoule energy measurement capability with photodiodes up to dozens of kilojoules pulse energy with petawatt lasers applications. We cover anything there, and we're the only provider of big calorimeters, detectors for kilojoule pulse energy level, ready to go for example, ignition facility applications. The way we differentiate ourselves is, I like to say, from a sales point of view, the partnership strategy and vision that we have a very, very reactive team, knowledgeable sales engineers providing technical guidance, not just on the detector to select and to use for their needs, but as well on the lasers themselves and the application and how they could improve their applications and their laser systems. So a team made of engineers, physicists, PhD, that's what we have in our sales teams here at Gentech, and really happy to help this variety of application out there. And once again, the customization capabilities, still in a cost-effective fashion. We're using our knowledge and the R&D money that has been injected over years to provide unique solutions. We custom-made those probes up to 100 kilowatts and more for continuous power measurement with a small footprint and options for managing back reflections, a variety of communication outputs and cable length and special calibrations specific and everything. So we're used to handling those specific projects effectively. And I'd like to mention one device that we made for, once again, petawatt lasers application. That's beam dump, absorbing more than 99.9% of the laser energy for petawatt lasers. That's a unique product, and we call it a portable black hole. That's something that is made on a custom base that we're kind of proud to provide to this field of application. Once again, partnership, customization capabilities, high data thresholds, and unique technologies for customers to focus on their developments and measure improvements with simple measurement capabilities.
That's great. So maybe, Phil, give us some examples of specific challenges that Gentech equipment addresses for engineers and researchers who are working with lasers and laser systems.
Yeah, okay. Specific challenges. There are many, and we pride ourselves to provide the guidance needed to get things done. One example that I can think of is about recalibration cycles. So we offer a straightforward process for recalibration using the NIST gold standards I've mentioned. But we help our customers as well to define the exact recalibration cycle that's valuable for their reality. Specifically in medical applications, for example, as drug sealing processes, where we can provide customized or adapted to their needs recalibration certificates with given power levels, wavelength, and so on. So sometimes it's hard for a customer to define exactly when they need to resend the detectors for recalibration, if that every 6 months, 12 months, 18 months, a week here, depending on the usage and how they could damage the detectors. What is the best cycle for checking on those probes? Another challenge I can think of was for these dual real-time power measurement beam profiling challenges I've mentioned before. Because there we released, based on this customer feedback, the BA series, the beam attenuator series, up to 1 kilowatt of laser power, going inline simultaneously to measure the least traceable power measurement and ISO compliant beam profiling images. So yeah, that was driven by customer challenges. Another one I like is the one we released, those wireless detectors. So you can go wireless, you have your enclosure, laser detector, and wireless communication. We have customer in need of not opening up the laser safety enclosures during the processes. They wanted the probe, the laser power meter, to be inside of the enclosure and not having to reopen up the enclosure every time between measurements. So we had released those this option with those applications in mind, and customers are pretty happy about it. And the last one, we think performance, accuracy, and robustness with our products, but we always keep in mind the business model of our customers and cost effectiveness. For example, we released the single pulse-to-pulse energy detectors, the QE series HR, we call it, up to 10 kilohertz pulse-to-pulse energy measurements, so 10 kilohertz repetition rate. We can do higher than that with the Max 6 series I've mentioned, but now up to 10 kilohertz, the package costs less than $2,000, so very cost effective and efficient. So yeah, our customers need to find the right partner to solve the challenges. We're here for that.
Well, on behalf of Laser Focus World, I'd like to thank our guest, Phil Legrand of Gentech Electro-Optics, for joining us for this PhotonicsNXT Fall Summit and for the very informative discussion about trends and challenges for measuring laser beams with high accuracy.
All right. Thank you, Justin.